This is the most exciting discovery I've ever made in my career, and I've been fortunate to make a few. Is it possible to reverse aging, not just slow it down, in a way that is permanent, right? We can treat diabetes, but if you stop taking the medicine, you don't stay cured. This would be a permanent reset of the body, and then you'd age out again. So we'll go to the next slide. The background that you need to know is that in 2012, a Japanese scientist, Shinya Yamanaka, made probably one of the biggest discoveries since the structure of DNA. And that is that if you turn on four genes, literally these four genes that I've shown you here, you can turn any cell from an adult into a stem cell called an induced pluripotent stem cell, or an iPSC. And this has been revolutionary in part because we can now take skin cells from adults and grow them into new tissue and inject them back into people. And we also don't need to take stem cells from human embryos, which of course was very contentious in the early 2000s. What we did was we took a leaf out of this book and we said maybe there's a subset of genes that can not reverse aging back to zero, because that would be dangerous. If I turned you into a lump of stem cells, you'd probably die within an hour or so. But if we did it in the right way, we might be able to reverse aging, say about 80%, and stop. And that's exactly what we found was possible. And we published this in 2020 on the cover of Nature magazine. So in the next slide, I'll show you some of the remarkable results that we got. So what we did was we didn't use all four of those genes. That would be toxic. We lucked out. We found out that leaving out one of those genes stops the cell from ever becoming super young. And those cells get younger, but they don't lose their identity. A nerve cell, in fact, regains its identity that it's lost during aging. So it was a super lucky discovery. And what we found in this paper was that when we treat tissues with age reversal, they can regrow and function again like a baby would. This is an optic nerve from a mouse that's been damaged. And what you would normally see from a young mouse was a bright orange strip. That's the optic nerve under the microscope. And each one of these little lines is a nerve that's coming out of the back of the eye from right to left towards the brain. And when we reprogram those nerves after the injury, they became young and they regrew back to the brain. And so we've come a long way since this first discovery. We've reversed aging in glaucoma, of course, mice in glaucoma. And we've also now cured many aspects of old age. In the next slide, you'll be able to see that, hopefully. This is a movie of a mouse who's had its eyes rejuvenated to be young again. So these are old mice. Ignore the poop. It's just a bit nervous. Now, a mouse that can see, a young mouse would move its head from left to right, or on the screen from top to bottom. This mouse is still blind. It's legally blind, and it cannot see these lines because it's not moving its head. But if we treat a sibling of this mouse at the same age, these are over a year old, and these mice tend to lose their eyesight pretty quickly. What we see in the next movie is that we can regain eyesight in these mice. What's happening is the nerves are remembering how to be nerves. Are we stuck on this slide, or can we skip to the next one? Okay, good. Thank you. So this mouse, which is looking a little bit ratty because it's old, hopefully you can clearly see that it's following the lines with its head. And we could measure the age of the eye, and it became young again, back about 80%. And those little chemicals that were on the DNA, which tell a cell how to fold the DNA, went back to how they were when the mouse was young. In other words, there's a memory of youth in every cell in the body that we've discovered that you can access like a reset switch using those three Yamanaka genes, OCT4, SOX2, or KLF4. We also know them as O, S, and K for short. So let's go to the next slide. This just was a remarkable moment. I was very proud of the team. This was led by a graduate student, Wancheng Lu, who really was close to quitting this project. And if there's a lesson here, it's never, ever give up. And he actually came into my office after trying dozens of different types of combinations of genes and failing. And he said, "I just can't do this anymore, David." And I said, you have to trust me. I believe you're on the verge of something really big. And literally, his next experiment was the one I showed you, where he could rejuvenate the eye. And he got the cover of Nature magazine, which is clearly a highlight for any scientist's career. Um, I was surprised that they put us on the cover, and I was even more surprised that they put this title, Turning Back Time, which is rather provocative. So next slide. Let's see where we are going from here. Now, some of the things we're doing in the lab are even more exciting. We are growing human brains. These are called organoids. We can grow human brain tissue, and we're the only lab that can age these forwards and backwards. We can make those little brains 80 years old and rejuvenate them. And what we find is that those brains get their ability to have brain waves back again. And we can see them by putting those brains on a little chip, which is the movie on the right, and see those little electrodes. And what we found now is we've actually rejuvenated the brains of old mice and mice with Alzheimer's disease. And when we do that, as I mentioned, we get a cure of these diseases. We can see that the mice get their memory back, ability to learn, and lost memories come back again, which is remarkable. What this means is probably in old people and Alzheimer's patients, those memories are not lost permanently. We just need to rejuvenate the age of the brain and they'll come back again.